Okay, so I guess we are live now. How many of you guys are able to hear me? Just drop a yes or no in the chat. Everyone who is able to hear me, just quickly drop a yes or no in the chat. Okay, so Rajesh says yes. So guys, we are going to start in about 5-7 minutes. Let's just wait for more people to join and then we are going to start. Right. Hi, Pettifogger. How are you? Till then, let me just complete the setup. Guys, we are going to start in about 5-7 minutes. Right. We'll just start in about 5-7 minutes. Uh, I'll tell you that, Petty Fogger. I'll explain everything. Don't worry. Mm, just give me 1 second, guys. Okay, cool. So also today we have Kunal with us as the TA for today's class. So Kunal and I will be taking doubts both from Unacademy as well as on YouTube. All those people who want to directly join at Unacademy can directly join here. Kunal, can you ping the link for the uh, Unacademy's class in the YouTube chat so that if anyone wants, they can like directly join here. Cool. Okay. Just wait for 2-3 minutes, Petty Fogger. I'm going to like answer all your queries. Don't worry on that part. Right. I'll also discuss what's the agenda for today, how we are going to manage things. Right. Okay, just give me 1 minute. Cool. Okay. Yeah, sure, Sridharan. I guess this will be helpful somehow. We will discuss few concepts that would be like helpful for you. Uh, Okay, Basil, I would suggest you to start from any one language. You should learn first a language. We are also organizing a programming camp this weekend. You can definitely join the Div 3, where we'll be starting from basic language constructs and other basic topics as well, right? Hi, Adraj. Hi, Harit. How are you guys? How's everyone? Are you guys able to hear me properly at YouTube as well? Is there any kind of voice issue on YouTube? You guys can ping me. Okay, so Basil, if you have already enrolled for the Plus course, so you can start from either Introduction to Java or Introduction to CPB or C++. If you have like no knowledge of competitive programming or data structures and algorithms, that both of the course, one is in Java, one is in CPP, will help you to build up the basic language concepts and initial problem solving concepts. That will give you a good head start in the longer run, right? You can like opt for that. Guys, is everyone able to hear me? Just spam a yes or no in the chat quickly. We want to like start really soon. So just quickly spam some yes or no's if you are able to hear me properly, right? Uh, cool. This will save some bandwidth. Cool. Makes sense. So, guys, today's lecture is in the continuation with the yesterday's lecture. So, we are running this micro course on Introduction to Number Theory. Right. And in this micro course, we are going to discuss about the basic and the fundamental steps that you need to learn in number theory. So in the last class, we have already taken a deep dive into Euclid's algorithm. We derived that how we can get an intuition on to derive Euclid's algorithm. We saw the Bennett's formula to get the golden ratio. Apart from that, we solved the whole Bennett's formula as well. Using that Bennett's formula, we derived the time complexity for the Euclid's algorithm. And we also saw some initial problems where we solved few of the problems using Euclid algorithm. And also we solved some problems using factorization. Is this point making sense to everyone? What we have already discussed, guys, are these points clear to everyone? Just quickly drop a yes or no. Cool, cool, cool. Okay, cool. So today we are going to discuss few more things. So today's class will be basically on modulo arithmetic. Now, modulo arithmetic is going to be a very, very important concept when you talk about competitive programming, and even if you talk about your normal coding interviews that you generally do, right? So whenever you get an online test, there are some concepts of modulo arithmetic that are frequently used in those kind of tests. So today's class are going to be helpful for those people as well. Apart from that, we will get a quick brief on what was Euclid's algorithm, and today we are going to discuss the applications around Euclid's algorithm. Is this point making some sense to you guys? Say yes or no, everyone. Just drop a yes or no in the chat. What's the agenda for today? Okay. Uh, just one more. So it's 9:05. We are just going to start in about 2 more minutes. Till then, if anyone has any doubts from the last class or something, if they want, till then, let me share the screen. Cool. Is everyone able to see the writing pad? The notes app, everyone is able to see, right? On YouTube as well. हाँ कुमार, कल वाले के कोड करेंगे, वहीं से स्टार्ट करेंगे. So let me clear the agenda for today, right? So today's agenda is going to be, we will revisit for 5 minutes what was the Euclid algo. से 2-4 मिनट में एक बारी फटाफट से देख लेंगे जो लोग नए हैं उनके लिए, ताकि बिल्कुल ही ब्लैंक लेक्चर ना जाए कि यूक्लिड एल्गोरिथम क्या है, क्यों यूज करते हैं. Then there was a problem. Before that problem, we are going to discuss about modular arithmetic, right? Basic modular arithmetic के बारे में बात करेंगे. Then there was a problem that we discussed yesterday, that was add a GCD from Spoj. We will code that because a lot of people were asking for the code of that problem. Right, we are going to code that add a GCD problem. Then we are going to see the extended Euclid algorithm. Then there's a concept of multiplicative modulo inverse. We will see that as well. And if we will be having some time, then we will try to solve some linear Diophantine equations, right? We'll solve some linear Diophantine equation. At least we'll try to start them. Or maybe if the code will be left, we can code in the next class. That will be on Thursday. If possible, if we are not able to even cover anything, then we will start for linear Diophantine equations on Thursday only. Does that make sense? Okay, Nikhil. Okay, Nikhil. Actually, we got a lot of requests for English on YouTube. So I'll try to keep a mix for that. I'll try to keep a mix for that. Yeah, yeah, Rajesh. No issues on that part. No issues. I'll give you a quick revisit on Euclid's algorithm. Guys, is this point making some sense? Is the agenda clear to everyone? What's today's agenda? Right. This is the second class on the micro course, the free micro course on number theory. Right. And what's the prerequisite for today's class? If anyone wants to know the prerequisite, the prerequisites are same. Basic elementary maths you need to know. Right. Apart from that, basic loops, if else, or I can say conditionals, and basic recursion that you need to know. Right. These are something that you need to keep in your mind for today's lecture. Right. Okay. So for all those who have not watched the first part, I would highly recommend you guys to go on the Unacademy's platform and watch the lecture 1 on introduction to number theory. This Euclid algorithm and all the derivation, all the mathematics has been very in detailed discussed there. So you guys should definitely check that out. That would be like worth a 2 hour watch, I would say. So let's just start. Let's just start with today's concepts. Okay. So let's just have a quick revisit on what was Euclid's algorithm. So if you want to calculate GCD of two numbers a comma b, if you want to calculate GCD of two numbers a comma b, what we saw in the last lecture, that we can write it as GCD of a comma b is equal to GCD of b comma a modulo b, right? We have already discussed this in the last class. Yes or no? We already discussed this part in the last class, guys. And how we are doing this, because let's say if b divides a with a remainder r, right? So you can write a is equals to bq plus r, right? And r is equals to what? A modulo b. So you can write a minus bq is equals to r. Now this equation, the LHS is completely divisible by a. Can we say that a mod a and bq mod a, these are going to be divisible by a? Then r is also going to be divisible by a. So can we say this part is equivalent here? And this is how we derive the Euclid algorithm. And the time complexity is going to be log to the base 5 minimum of a comma b, big O in this term, right? This is we have already discussed. Drop a yes or no in the chat, guys. Quickly drop a yes or no. We have already discussed this much part, right? And this phi is what? This is the golden ratio. How we derived this golden ratio? We used this equation x square minus x minus 1 equal to 0, took out the roots, took some observations like x square is equals to x plus 1. Then what will be the value of x cube? It will be x into x square. What is the value of x square? X plus 1. So x into x plus 1, this is x square plus 1. What is the value of x square? X plus 1. So this is 2x plus 1. So on and so forth. We derived that. This gives you the relation for Fibonacci. Right, we already derived this. You guys can check that out. And using that, we calculated the golden ratio and we calculated this time complexity. Although the proof is not going to be very much relevant for competitive programming, because you just need to be very sure about the time complexity of the algorithm. But if you know the proof, then it is always going to be a better thing to know, because just knowing how to do things and is never going to give you a very long run in this race, I would say. But if you know everything, how they work and why they work, then this is going to be beneficial for you guys. Right. So this was all we discussed in the last lecture, and we solved some three problems, I guess, based on them. Does that make sense? We also saw the relationship between GCD and LCM, that LCM is equals to product of two numbers upon GCD of two numbers. We have already seen that, right? Cool. So let's just start. So in today's agenda, we are going to start with modular arithmetic. Okay. So what is modular arithmetic? Now, arithmetics are what? Arithmetic operations you have already learned about, right? Plus, minus, divide, multiply, so on and so forth, right? Okay. What's this modular arithmetic? When those arithmetic operations are combined with some modulo properties, this is what? The modulo operator. Then that paradigm is called as the modular arithmetic. Before taking a deep dive, इससे पहले कि हम देखें कि क्या है ये, let's just first think why it is even there in the first place. Why do we even need to learn it? So a lot of time you will see that you need to print answer modulo 10 raised per 9 plus 7 in competitive programming. How many of you guys have seen this term, that you need to print the answer modulo 10 raised per 9 plus 7 or 10 raised per 11 plus 7 or anything like that? How many of you guys have seen something like this? Drop a yes or no, both at an academy as well as on YouTube. Right. Okay. So what happens in the case is that, let's say that there is a problem where you are given the length and the breadth of a rectangle, right? And you need to print the area. Now let's say that length is of order 10 raised to the power 12 and breadth is of order 10 raised to the power 12. Then what will be the order of area? Uh, Yashvir, are you not able to send the chat? I guess rest of the people are able to send their messages. Can you retry once? So if the length is of order 10 raised per 12, that is maximum, it can be like 10 raised per 12. The breadth can be of order 10 raised per 12, that is the worst. Breadth can be 10 raised per 12. So area can also be of order 10 raised to the power 24. Say a yes or no. Drop a yes or no, guys. Okay. Now, do you think you will be able to store it in any variable of C++, let's say, like let's say long int? Do you think this is within the bounds of long int? No, you won't be able to store that, right? So a lot of time what happens is you have to print your answer modulo this number. Why? Because this is approximately inside the range of integer of a 4 byte, a 4 byte integer range. This is inside the range of integer of 4 byte. So you are able to manage your answers, right? You are able to manage the answer. You are able to give them a certain bound that, okay, we can calculate it because calculating area is a one task, length into breadth, but this can overflow, this can give you an overflow on the variable. So to keep the things in bound, we need to like do 10 raised per 9 plus 7. Does that make sense? Everyone just drop a yes or no in the chat. Okay, cool. So let's just see what happens in various of the cases. Okay, so let's say that length is of order 10 raised to the power 12, breadth is of order 10 raised to the power 12, right? Okay, so what you need to do, you need to calculate the area and print the area modulo 10 raised power 9 plus 7, right? Okay. Now, this seems a trivial task, right? This seems a trivial task. Why? Because area is going to be length into breadth. We need to just get modulo 10 raised power 9 plus 7. Length into breadth is, let's say, 10 raised to the power 24. Modulo 10 raised power 9 plus 7. And it will give us some value. How many of you guys think this is going to be such trivial? Say yes or no. But you won't be able to store this area, right? If you will just directly multiply it, you won't be still able to store this area. So we need to simplify it further. So for this simplification, we came up with the concept of modular arithmetic. Right, we came up with the concept of modular arithmetic. Now let's just see what this modular arithmetic says. So there are some rules. There are just like some simple rules using which we need to calculate the modular arithmetic. So what are the rules? It says that if you want to calculate a plus b modulo c, right? And let's say a and b are of very high orders. So it will be equal to a mod c plus b mod c whole mod c. And don't you guys think this makes sense? Because either if you are adding it first and then taking a modulo, or you are like first taking the modulo, then adding it, and then again taking the modulo, it is going to be the same thing. How many of you guys agree with this? Drop a yes or no in the chat. Let's say we took something like 5 plus 7 modulo 2. What will be 5 plus 7? 12. How many of you guys think it will be 12? Right. And 12 mod 2 is going to be what? 0. 12 mod 2 will be 0. Okay, let's just see in this terms. So 5 mod 2 plus 7 mod 2 whole mod 2. So 5 mod 2 is going to be what? 1. 7 mod 2 is going to be what? 1. And do you think we have reduced from 5 to 5 and 7 to 1 and 1? Whole mod 2. This will be what? 2 mod 2. It will be again 0. So do you think this satisfies? ठीक है जावेद, थोड़ा सा बता देंगे एक बार कैटल नंबर की रिकरेंस वगैरह लिख दूंगा, कोई दिक्कत नहीं है. Guys, do you guys think this is making sense? So we have reduced our numbers, right? So if at any point of time you are taking a number modulo m, so the result will be going from the range 0 to m minus 1. How many of you guys agree with this on me? Right. If you are going to compute number modulo m, any number modulo m, then the final answer is going to be inside the range of 0 to m minus 1. You can like definitely check that. So let's say 5 modulo 2 is going to be 1, 4 modulo 2 equal to 0, 3 modulo 2 equal to 1, 2 modulo 2 equal to 0, so on and so forth. So it's like 0 to 2 minus 1. This is the range for modulo 2, right? Does that make sense? No, Ayush, I'm watching the YouTube chat as well. That's why I said Javed that I'll explain a bit of Catalan number. Don't worry. I'm watching both of the chats, but sometimes uh, it gets flooded. So there is Kunal also with me who is helping me as a TA. Right? Cool. Guys, is this point making sense? So what we can do, A plus B mod C is equals to A mod B, sorry, A mod C plus B mod C whole mod C. Right. Okay. What will the value of A into B mod C? Anyone? What do you guys think will be the value? Guys, what will the value of A into B mod C? Anyone? So it is going to be A mod C into B mod C whole mod C. Does that make sense? Myth Jan, I'll discuss this part. A raised to the power B modulo C. I will discuss this one, don't worry. Right, okay. Now how about A minus B modulo C? What do you think this value will be? A minus B modulo C. Let's see who cracks this. Anyone who can tell me what is A minus B modulo C? Why you deleted Adaraj? I guess that was correct. Although I was not able to see completely, but seems correct. No myth, this won't be correct. Sujit seems correct. What about the rest of the people? Guys, try to respond. What do you think will be the value of A minus B mod C? Cool. Let's just take an example. Let's just take an example. So let's say you are going to calculate uh, 13 minus 4 modulo 5. So if you will just directly do 13 modulo 5 minus 4 modulo 5 whole modulo 5. This should come what? 13 minus 4 is what? 9. 9 modulo 5 is what? 4. Here it will come what? 13 modulo 5 is 3 minus 4 modulo 5 is 4 modulo 5 and minus 1 modulo 5. This will be like something else, right? This won't work. If you will just do A mod C minus B mod C whole mod C, it won't be giving you the correct answer always. Does that make sense? How many of you guys are able to see this? That if you write 13 minus 4 modulo 5 and if you will just directly follow A plus B and A into B identity, so it won't be giving you the right answer. Why? Because after the modulo operation, the values will be reduced to 0 to m minus 1. Now it can happen that the first value becomes lesser than the second value and it will go in negative direction. So what we need to do instead, what we can do here is, anyone, what we can do here? So instead what we can do, you can write 13 modulo 5 minus 4 modulo 5 plus 5 mod 5, right? How many of you guys think that this and this are equal? right? Why this is equal? Because 5 mod 5 is eventually 0 only, right? We are not adding a new quantity. 5 mod 5 is eventually going to be 0 only. No issues on that part. Okay, so let's say 13 mod 5 is what? 3. 4 mod 5 is what? 4 plus 5 mod 5. Now this is going to be what? This value A will be in the range 0 to m minus 1. This value B will be in the range 0 to m minus 1. Right? Whatever their subtraction is going to be, their subtraction is never going to be lesser than minus m. Can we say that? So if we'll just add m, it will just neutralize the effect. So you can see here is that 5 plus 3, 8, 8 minus 4, 4 modulo 5 comes out as 4, and this was also coming as 4. So what we can write is A minus B modulo C is equal to what? A mod C minus B mod C plus C mod C. Is this point making sense? Yes, Somadeep, this will help us to make the overall quantity always positive. And let's say if the quantity was already positive. Let's say if the quantity was already positive. Let's say 13 minus 12 mod 5. So 13 mod 5 is what? It will be 13 mod 5 minus 12 mod 5 plus 5 mod 5. So 13 mod 5 is equal to what? Again 3 minus 2 plus 5 mod 5. So this is what? 3 minus 2 is 1 plus 5. 6 mod 5 is 1. And if you would have calculated this, it would have also given as 1. So even if the subtraction becomes positive or negative, this plus 5 is not changing the answer. It's just neutralizing the negative effect coming if uh, the operand B becomes higher than the operand A after the modulo operation. Does that make sense? Good evening, Mansi. Guys, does that make sense? Is this point, are these three identities making sense to you? Everyone, just spam a yes or no in the chat if these three identities make sense. Everyone. Cool? Okay. Now, can anyone tell me what's the value of A by B modulo C? Anyone? What's the value of A by B modulo C? Yes, Ayush. That won't take any change because KC modulo C is always going to be 0, right? Where K is like any, uh, KC is any multiple of C. Okay, Rajesh says A mod C divided by B mod C into C whole mod C. Okay, do you guys think that will be correct? Okay, so let's just see. A by B mod C. Few people are saying that it will be something like A mod C by B mod C, then multiplied by something, then mod C, kind of. Right? I just told you guys that any number modulo C comes within the range of 0 to C minus 1. So can we say that this denominator can sometimes become 0? Do you guys think that? Do you guys think that this can become 0? So do you think this will always be a feasible option to go for? No. So we can't just directly calculate A by B mod C, right? If we want to calculate A by B mod C, we can't just like directly do some similar identity. We need to do some extra work, right? We need to do some extra work. We are going to discuss that. We will be discussing that, right? We will be discussing that. We need to do some extra work. Is this point making sense? Yes, Shad. So like there are theorems. If C is a prime number, if C is a prime number, then this will be like A mod C into B raised to the power C minus 2 mod C, so on and so forth. But like there are some theorems for that, but we are going to discuss that. Maybe we can discuss that later. Right. So direct these kind of identities don't apply for A by B mod C. Does that make sense? Till now, is everything clear to everyone? Drop a quick yes or no in the chat. I want a quick yes or no, guys. Cool. Okay, cool. So let's just try to, so whatever we have learned till now, let's just try to solve one very important problem. And this problem was asked to me in my online test for one of the companies that I appeared for. Uh, so the problem is, so the problem that I got was a bit modified. I'm giving you a simpler version, which will be used as a subroutine only. So you are given two values, let's say three values, A, B, and C, and you need to return A raised to the power B modulo C. Right, you need to return this value. How you guys can do this? Anyone with any approach? How we can solve this? Guys, any approaches in the chat? Think about it, how you can solve the problem. It's one of the most frequently asked problems in interviews nowadays. Anyone? Yes, Shad. Okay, Dilip. What about rest of the people? Myth says observe a pattern. What kind of pattern you can observe, Myth? What about rest of the people? Dilip says recursion. Okay. Yes, we can definitely do this with recursion. Binary exponentiation. Okay. So, Medip, if you want constraints, let's say A is of order 10 raised to the power 3 and B is of order 10 raised to the power, let's say 8 maybe, and C is of order 10 raised to the power 9. Like quite big values you can have, right? Okay, Harit, makes sense. Anand says would depend on B. How it would be depending on B? Anand, you're on the right track. Anshul, what log? Are you telling the time complexity for your algorithm? Guys, think about it. Anyone who can give me any maybe solution for this? Yes, Anand, you're on the right track. What about rest of the people? And operator. Okay. Chanchal, what you are going to do with that? Guys, anyone with any hints? Anyone with any kind of hint, maybe? Okay, let's just first try to solve a simpler problem. Let's just first try to calculate A raised to the power B. Let's just first try to solve a simpler problem, A raised to the power B. Now, what will be a brute force approach for this? The brute force approach will be to multiply A with itself B number of times. Does that make sense? Yes, Rahul, you're on the right track. Right. Chanchal says power. Chanchal, let's say you can't use power and power function doesn't give you dysfunctionality, A raised to power B mod C. It doesn't give you that. Right. Okay. So this will be the brute force approach and the time complexity will be big O of B. Right. That you are going to multiply A B number of times. Make sense? Okay. Now, how about if I define a function f that will takes A and B and it returns A raised to the power B? Can I think of something like whatever is the value of A by A comma B by 2 is, a comma b by 2 is, if I'll just multiply both of them, can I get a raised to the power b? It is simply saying a raised to the power b is equals to a raised to the power b by 2 into a raised to the power b by 2 if b mod 2 double equal to 0. That is b is even. Is this point making sense? Is this recurrence making sense? Guys, is this recurrence relation making some sense? Right. Okay. So what is the time complexity of this algorithm? People say is log b. Okay. What about rest of the people? What do you guys think? Right. Okay. So if we can just compute a raised to the power b just once and avoid this recursive call, it will be like from b you reduce to b by 2, then you reduce to b by 4, then you reduce to b by 8. Let me just drop it up. So on and so forth. And these are what? Log b terms. So we will be able to solve it in big O of log b if this recurrence relation holds true. Does that make sense? Does that make sense, guys? Okay. So now, don't you think this is going to be a trivial task to calculate a raised to the power b mod c? Why? Because if anyhow you are able to calculate a raised to the power b by 2 mod c, a raised to the power b by 2 mod c, then what would be my answer? My answer will be what? This mod c into this mod c whole mod c. Can I say that? How many of you guys agree with this? Say yes or no in the chat. Right. And this is true when b is even. What about when b is odd? What if b is odd? Then can I say it will be equal to a into f of a comma b minus 1 mod c, right? Or you can just drop a mod c into this mod c whole mod c. Make sense? Is this point making sense? So will this recurrence relation hold true, guys, for b odd? B is odd because this will be what? Let's say you want to calculate a raised to the power 7. You will reduce it to what? A raised to the power 6. Now from now it is equal to this recurrence relation which will be what? A raised to the power 3 into a raised to the power 3. Now again a raised to the power 3 you can reduce it to a raised to the power 2 into a raised to the power 2, so on and so forth. Does that make sense? Can we solve it like this? Okay, so let's just try to code it. Let's just try to code it. I guess there is some bandwidth issues. Let me just close this one. Cool. Okay, so this is modular exponentiation dot cpp. So we'll start with the basic template, right? Okay. So we'll write a function ll mod recursive. It will take a, it will take b, it will take c. Does that make sense? Guys, everyone able to see this? Drop a yes or no in the chat. Guys, everyone is able to see this? Drop a yes or no in the chat quickly. Okay, cool. Now, what should be the base case for this recursion? What do you guys think should be the base case for our recursion? Anyone? What should be the base case? Anyone? Yes. A raised to the power 0 is always going to be 1. Can I say if b is double equal to 0, then always return 1? Does that make sense? Guys, is this point like making some sense? This will be the base case. Okay. Now you have two cases. That is if b mod 2 is 0, else something. Right? You have two cases. That is if b is even or b is odd. Does that make sense? right? So what should be the answer in both of these cases? Anyone? What should be our answer in these cases? We have already discussed the recurrence, right? So let's say we anyhow calculated LL temp is equals to mod recursive a raised to the power b by 2 mod c, right? We anyhow returned got this. So what will be my particular answer? It will be, you can just directly return from here temp mod c into temp mod c whole mod c. Does that make sense? Guys, is this point making some sense? Say yes or no. Cool. Okay. What about this one? I can just calculate LL temp is equals to mod recursive. Now, instead of going to b minus 1, how about I calculated a raised to the power 7 by 2. What is a raised to the power 7 by 2? It is going to be equal to a raised to the power 3. So can I do just like, if I just calculate a raised to the power b by 2 comma c, then maybe I can return a mod c into temp mod c into temp mod c whole mod c whole mod c. Does that make sense? This can also be true, right? This can also work. Instead of going to b minus 1, maybe I can just do this one, right? How many of you guys agree with this? Say yes or no in the chat. How many of you guys agree with this? Guys, any doubt? What will be the time complexity here? What will be the time complexity here? Log b. Will the time complexity be equal to log b, right? Okay. What will be the space complexity? The time complexity, is big O of log b. What will be the space complexity? Anyone? Sujit says O of n. What is n here, Sujit? We don't even have a parameter n. Okay. Adaraj is on right track, I would say. Log b. What will the space? We are not taking any extra space apart from the recursive stack, and the depth of the recursion is still what? Log b. So the space will be also equal to log b. Does that make sense? Can we optimize? Can we like anyhow optimize our approach to maybe do something better? So like time is like super optimized. Maybe we can get rid of this recursive space. So can we guys implement a mod iterative exponentiation with LLA, LLB, and LLC? Can we drop any exponential, iterative exponential version for this? How we can do that? Let's just see. So to do this, what we can do is, you want to calculate a raised to the power b mod c, right? You want to calculate this. Uh, sure, Salah, but most of the people do prefer black, so that's why I've kept it black, right? Anand says, you told when b is odd, we need the result of b is even, then answer into a. Yeah, Anand, you can either do this or maybe you can do this one as well, right? Is equals to f of a comma b by 2, f of a comma b by 2 into a. This will also be equal to say this one only, na? Right? Is there any change? Because like a raised to the power 7 is what? A into a raised to the power 3 into a raised to the power 3. 7 by 2, 7 by 2. Make sense? Cool. Huh. So we want to go to the iterative version. How we can go to the iterative version, guys? Anyone? So the number of operations we want to make is going to be log b operations. These are the number of operations that we want to make. Right? This is the constraint that we have, right? So what we can do? We can just do a simple while loop, and every time from b we can reduce b to b by 2, then to b by 4, so on and so forth. We can do this. Guys, say yes or no in the chat. Can we like do this? And every time what we can do, we can update a to become a square, then a raised to the power 4, so on and so forth. If like this is going, if this is even, otherwise if b is currently odd, then we can also multiply a with 1 power as well, just like here, just like we did in this recurrence. If like b was odd, then specifically multiplied once a as well, otherwise just exponentially grow the power. Does that make sense, everyone? So how this thing will look like, let's say we want to calculate a raised to the power 7. So from where should we start? We will start from 1, right? We will start the answer. We will start the answer from 1, and currently a is equals to, let's say, 3. We want to calculate 3 raised to the power 7, and b is equals to 7, right? Okay, and answer is currently 1. Okay, so is b odd or even? Is b odd or even? Yes, Soumyadeep. Is b odd or even? Odd. So what we need to do? We need to multiply a to our answer. So answer becomes 3. A is still 3. B is 7. Now next time what we need to do? We need to update a to become a square, and make b to b by 2. So a square is what? 9. B by 2 is what? 7 by 2 is 3. And answer is still 3. Does that make sense? Does that make sense? Guys, say yes or no. Okay, so b is still odd. B is again odd. We will multiply answer to a. So 3 into 9 is 27, 9, 3. Now this time 9 into 9, 9 is 81, 3 by 2 is 1, and this is still 27. Now this is 1, this is odd. We will multiply 27 with 81. This will give some value, let's say. And then we will do 1 by 2, right? We will do 1 by 2, which will be, it will become 0, right? And this will become 81 into 81, and this will be 27 into 81. And if you'll carefully analyze, 27 into 81 is what? 3 raised to the power 3 into 3 raised to the power 4, which is 3 raised to the power 7. So can I say our answer is containing the right value? User, I'm not sure. You need to like check the participation criteria once. I have not seen this case till now. Right, so let's just try an iterative version, and this iterative version we are also going to include modular. So let's say long answer is equals to 1, right? And at last we are going to return this answer only. Okay, while we will check till b is not equal to 0, yes or no, right? And every time we will check if b and 1, this is same as checking if b is odd or even. If b and 1, or let's just avoid, let's just do it in simpler way. If b mod 2 not equal to 0, right? If b is odd, then what you need to do, you will do answer is equals to answer into a. Now we need to do this answer into a in terms of modular. So this will be answer mod c into a mod c whole mod c. Does that make sense? This will be the case here. Okay, irrespective of the fact that b was even or odd, every time you need to do a is equals to a into a. Every time we need to do this, and again in terms of modulo only we need to do. So this will be a mod c into a mod c whole mod c, right? And we need to reduce b every time, right? So b is equals to b by 2, or you can also write b right shift 1. That will also do a division by 2. Does that make sense? And we'll just directly return the answer. So let's just see what the answer comes. So let's just ll a1 is equals to mod recursive. We need to calculate 3 raised to the power 7 mod, let's say 5. A2 is equals to, let's just calculate mod iterative, 3 raised to the power 7 mod 5. Let's just see out a1, or I can just do log a1 a2. This log is not directly available. I have like written a template for this log, right? Okay, so let's just try to run it. I hope this works. Okay, both are coming too. Does that make sense? Let's just take 13 raised to the power 7 mod 7 maybe. Both are coming 6. Guys, is this let's just see if this is correct or not. So maybe we can open the Python console, right? Let's just open the Python console to see if our answer is correct or not. So first let's just calculate 13 raised to the power 7. This is this value, mod 7 6. Right answer. Let's say 3 raised to the power 7 2187 mod, we did 5 I guess, 2. So seems fine, right? Is the code seems fine to everyone? What's the time complexity here? What's the time complexity here? Big O of log n. And what's the space complexity here? Big O of 1, right? uh, I'm not using from C++ Python. I've opened a separate console, user. I've opened a separate console for Python. This is a text editor that I'm writing CPP in. Guys, is this point making sense to everyone? Quickly drop a yes or no in the chat. Okay, till now everything is clear. Shall we move forward to the more advanced concepts for today? Guys, shall we move forward to the more advanced concept for today? I want a quick yes or no from everyone. Cool. Okay. User is saying no. User, what doubt are you having? Also, guys, please make sure that you log in with your original name. What? Otherwise, it becomes a bit hectic to notify you guys. Okay, okay, makes sense. Cool. So now, let's just tell me how many of you guys have heard about extended Euclid algorithm? How many of you guys have heard about it? Say a yes or no in the chat. If you have heard anywhere about extended Euclid algo. Shad is saying for even power, we don't need to write it explicitly. No, Shad, why do you need to write explicitly for even power? Anytime if the power is odd, because you will somehow reduce it to 1, right? Either you reduce it to 2, 3, 5, anywhere. You are always doing division by 2. You will either reduce to 1. Every time you will reduce to 1, either you reduce to 2, then also 2 by 2 is going to be 1. 3 by 2 is also going to be 1. 4 by 2 is going to be 2, then 2 by 2 is going to be 1. You're always going to reduce to 1. So you are always going to reduce to a odd number. Does that make sense? Right. So we just need to explicitly write for that case. Yes, Piyush is also right. Cool. Yeah, guys. So how many of you guys have heard about extended Euclid algorithm? Okay, let's just see. Let's say, guys, properly see what I'm writing. Let's say we have two numbers, A and B, and their GCD is like GCD of A comma B, right? We have some GCD G, right? So can I say that this equation holds true? Can I say this holds true? Rahi and Azreen, do you want some more problems on the previous concept of modular exponentiation? Do you want some more problems on that? Guys, does this equation holds true if you have two numbers A and B, then AX plus BY is going to be equal to GCD of A comma B for some value of X and Y? Can I say that this equation holds true? Guys, say yes or no. Because the LHS is completely divisible by G. LHS is completely divisible by G because GCDs are of what? A and B only. So can I say A mod, sorry, this is AX is what? Some multiple of A. So AX mod G is equal to 0. BY mod G is also equal to 0. And G mod G is also equal to 0. So this equation will hold true, right? So we can write AX plus BY is equals to GCD of A comma B. And we know that GCD of A comma B is equals to GCD of B comma A modulo B. Does that make sense? So what the problem is that we need to calculate these coefficients X and Y for this particular equation, right? For this equation, we know the value of A, we know the value of B, we can easily calculate A comma B. We want to get the value of X and Y, right? We want to get the value of X and Y. Does that make sense? How can we get it? Any ideas on whatever you have learned till now? Let's just take an example. Let's just take an example, right? So let's say A is equals to 35, B is equals to 15. What's the GCD of both of these? 5. So can I say AX plus BY will be 5 for some integral values of X and Y? For some integer X and Y? What will the value of X and Y? Can I say if X is equals to 1 and Y is equals to -2, then it will be equal, then this equation will hold true. So we want to calculate this X and Y. Now you have just one equation. You have one equation and you have two variables. But this equation is special. This equation is special. Why? Because in the RHS you are having GCD of A comma B. How can we solve it? How can we solve it? So these kind of equation where you are seeing something like AX plus BY is equals to C, where C is equals to some multiple of GCD of A comma B, These kind of equations are called as linear Diophantine equation, right? Although we will discuss about them in much more detail later. But first of all, tell me how you can solve this equation. Shad says take modulo on both sides. Then what will happen, Shad? You will get something like what? Ax plus by, ax mod GCD plus by mod GCD equals to 0. Then what will you do? Will you be able to get the value of x and y? Anyone else in the chat? Anyone else? Guys, again, math incoming. I'm telling you guys, math incoming. So just beware. Yes, so Piyush says we can loop on different values of x and y and get the values. But that is going to be a very hefty task, right? Because there can be a lot of different values for it. There can be like, if these are of order of 10 raised per 9, if the numbers are of order 10 raised per 9, then that will be of very high time complexity, right? Okay. Let's just see how we can solve it. Let's just see how we can solve it. Okay. So we have written that ax plus by is equals to GCD of a comma b. Yes or no? Can I say that ax1 plus by1 will be equal to GCD of b comma a modulo b for some value x1 and y1? This is x1 and y1. This is x and y. Can I say that? Guys, can I say that? Which is eventually equal to what? GCD of a comma b only. Right? This is eventually equal to GCD of a comma b only. When you were having GCD of a comma b on the RHS, these were the coefficients. When you are having b comma a modulo b here, do you guys think the coefficient should change? So we can change the coefficients to bx1 plus a modulo b y1 is equals to GCD of b comma a, sorry, b comma a modulo b. Can we write it? Say yes or no. Guys, do you guys think this will be working fine? Guys, is there any kind of lag on YouTube? Just quickly spam a yes or no if you are facing any kind of a lag. Guys, is there any lag? Kunal also, can you like just quickly check if there is any lag on YouTube? Uh, no? Guys, sometimes I stop speaking so that you guys can think. So don't treat it as a lag, right? I can't speak like for 2 hours continuously, right? It sometimes you have to think. So I just stop speaking at that point of time. Okay. Guys, this point is clear to everyone? Okay. Now what we can write for a modulo b? Can we replace a modulo b with a minus b into floor value of a by b? Does this holds true? Does this holds true? Guys, say yes or no. So can we write bx1 plus a minus b into floor of a by b y1 is equals to GCD of b comma a modulo b, right? Can you say that? Cool. So let's just write it again. So this is bx1 plus a minus b into a by b y1 is equals to GCD of b comma a modulo b. And you know GCD of b comma a modulo b is equals to what? GCD of a comma b. Can we write it? And we already know GCD of a comma b is ax plus by. Can we say that, guys? So bx1 plus a minus b into floor of a by b y1 is equals to ax plus by. Can we write it? Okay. Now let's just simplify them a bit so that coefficients of A are on one side, coefficients of B are on one side. So this is bx1 plus ay1, right? This is bx1 plus ay1 minus b into floor of a by b y1 is equals to ax plus by. Simplifying this a bit, if we can like simplify this a bit, what value can we get? What will be the coefficient of b and a here? Can I write the coefficient of b is going to be x1 minus floor of a by b y1, right? Plus coefficient of a is y1, which is equals to ax plus by. Can we say that? Somadeep is asking how we are. Jack Cardino, please let me know what's your doubt. Somadeep, can't you write a modulo b is equals to a minus b into floor of a by b? Let's say you are dividing 7 with 5, right? 7 modulo 5 is 2, or you can write it as what? 7 minus 5 into floor value of 7 by 5, right? 7 by 5 is what? 2. Just a second, I guess I wrote it wrong. Let's just take two values. Uh, let's say 13 modulo 3. Let's just take this, right? 13 modulo 3 is what? 4. And if we'll just do 13 by 3, it will be coming what? 13 minus 3 into 13 by 3, right? So 13 by 3 is what? Oh, sorry, this is 1. This is 1. 13 by 3 is again what, guys? 4. 4 3s are 12. So 13 minus 12 is again equal to 1. So this both holds true, right? Cool. So guys, till now is everything clear? We have just simplified both the equations. Simplify both the equations. Now comparing coefficients of A and B. We are comparing coefficients of A and B. Why? Because X is different, X1 is different. X1, X1, Y1 are for what? GCD of B comma A modulo B. And XY was what? For GCD of A comma B, right? So these are different. So comparing, so what we get? X is equals to coefficient of A, y1. Coefficient of B, y is equals to x1 minus A by B of y1. Do you guys think we have got these two values? Guys, say yes or no. So how we solved it? We solved that x will be equal to y1 and y will be equal to x1 minus A by B times y1. And if anyhow, so we have already wrote the equation that ax plus by is equals to GCD of A comma B, and ax1 plus by1 is equals to GCD of B comma A modulo B. So this is what? A recursive relation. A recursive relation that anyhow, if you are able to calculate this recursive equation, if anyhow we are able to calculate the value of this recursive equation, we will get the value of x1 and y1. So we can get the value of x and y from this equation. Yes or no? Guys, say yes or no in the chat. Quickly, just drop a yes or no in the chat. How many of you guys agree with this? How many of you guys agree with this? Any step that you want me to repeat, tell me now. Any step that you guys feel that should be repeated, please let me know. Seems fine, guys? Seems fine? Okay, what will be the base case of this recursion? What should be the base case? Okay, चलो पहले बेस केस वगैरह बाद में देखते हैं गाइस. पहले ये वाली स्लाइड देखो, यहीं पे मेन डेरिवेशन है, इस पे और इससे पिछले वाली पे. मैं ये पूरी की पूरी स्लाइड शेयर कर दूंगा, पूरे के पूरे नोट्स शेयर कर दूंगा, इसलिए आज थोड़ा सा साफ सुथरा भी लिख रहा हूं मैं. आई होप. तो let me know if you have any doubts. Soumyadeep is saying, can you repeat how x is equals to y1? ठीक है. Soumyadeep, in this equation where I'm pointing, can you see we have ax plus by on RHS? We have this and this on LHS. So coefficient of b is what? Y here and this here. So this value and this value is going to be equal. So y is going to be equal to this. And coefficient of a is y1 on the LHS and x on the RHS. So this is going to be equal. Can I say that? We are comparing coefficients. Is this point making some sense? Guys, is this point, does this holds true? This holds true? Cool. Okay. Now, oh, I'm sorry. Just a second. So how I can delete this page? Okay, we'll see. We'll see. Cool. So now let's just see what will be the base case. Let's just see what will be the base case. What will be the base case, guys? We know that we are using the Euclid algo to go from a comma b to GCD of b comma a modulo b. So what was the base case here? When b becomes equals to 0, what was your GCD? It was a, yes or no? So in ax plus by is equals to GCD of a comma b. In ax plus by, GCD of a comma b. So b becomes 0. So this is ax is equals to, and this GCD becomes what? A. So x becomes what? 1. Yes or no? What will the value of y? Can I say y will be equal to 0? Right. So this is our base case. Let's just try to code this one. Let's just see how we can code it. So this is our code for extended Euclid algo.cpp. Guys, is the derivation clear to everyone? Derivation में किसी को कोई doubt? Anyone? Okay. Now one thing. To get the answer from this recursion, every time to calculate x and y, we need both x1 and y1 as well as the GCD. So we need 3 values simultaneously in our recursion. Say yes or no. So what we can do is we can make a class extended Euclid triplet. Right. Let's just have some public variables here. Let us say LLGCD, LLX, LLY. This class makes sense to everyone? Right? Okay. Now we'll write a function that is going to return this external Euclid triplet, and we will call this as GCD extended Euclid. Right? Okay. We are going to pass A and B. Make sense? Guys, drop a yes or no. Does this make sense? Cool. Kunal, can you like quickly take some doubts both on Unacademy as well as on YouTube? There are some doubts popping. Let me just complete the code. After that, I'll join you for the doubts. Right? Okay. Now, what was the base case? Base case was if b becomes equals to the 0, then we have to do something. Right? We'll fill the base case later. But otherwise, what you need to do? You need to call the extended Euclid triplet temp is equals to, you will call whatever the answer for b comma a modulo b is, just get me that. What will be my answer? What will be my answer? My answer dot GCD will be equal to what? Whatever is temp dot GCD. Why? Because GCD of A comma B is equals to what? GCD of B comma A modulo B. So whatever temp dot GCD is, my answer dot GCD will be same. Okay. My answer dot X. What will be the value of my X? Can I say temp dot Y? See here. Just a second. Can I say X was equals to the smaller Y1? Yes or no? Right? Okay. Then what will be the value of my answer dot Y? Anyone? What will the value of my answer dot Y? It will be equal to whatever temp dot X is minus A by B, right? A by B will directly give you the floor value into temp dot Y. Will this be my final Y? And can I say I can just return my answer from this position? Quickly just drop a yes or no in the chat. Do you think this will be, if anyhow we have got the value of temp, we can, this is how we can get the value of my answer and return it? Guys, say a yes or no. Is this code clear to everyone? What will the base case? So now in the base case, we will do what? Base dot GCD. What's the GCD? If B is equals to A, GCD equals, B is equals to 0, GCD equals to A. Base dot X equals to 1 and base dot Y equals to 0. Does that make sense? And we can just return base from this point. Yes or no, guys? Okay, cool. So let's just take some values. Let's say LL A comma B, C in A comma B, right? Okay. Now we will just calculate our extended answer is equals to GCD of extended Euclid A comma B, right? Let's just log answer dot GCD. So we took the example for 35 and 15. So let's say 35 and 15, right? And this is going to be true for A greater than B, right? 35 and 15. Let's just see what happens. We don't need to initialize it, right? We don't, we need not to use the new operator every time. It will be initialized with some garbage values. We are always going to reassign it, so no issues on that part. Guys, do you think this is coming true? How many of you guys says yes or no? Let's just take for one more. Let's say 30, 20. So the GCD is going to be 10 and the values are going to be this. So have we solved this equation? Yes or no, guys? Seems perfect. Everyone just drop a quick yes or no in the chat. Cool. Okay. Now there comes some applications of this extended Euclid algorithm, right? This extended Euclid algorithm is used in a lot of places, right? Guys, I've like left this rough space, just avoid it. So one of the key application of extended Euclid algo is to calculate multiplicative modular inverse, right? Is to calculate multiplicative modular inverse. How many of you guys can tell me what is multiplicative modular inverse? How many of you guys know about it? How many of you guys know about it? Say yes or no in the chat. Guys, drop a yes or no if you know what is a multiplicative modular inverse. Definitely, Shad, it will make some difference. You can definitely implement that. Guys, how many of you guys know about what is a multiplicative modular inverse? Okay. But before that, how many of you guys know about modular congruency? How many of you guys know about modular congruency? Again, math incoming. Math incoming again. Chanchal says yes. What about rest of the people? Do you guys know what is modular congruency? So there's a very good article on modular congruency, I guess. Okay, so I'll share it with you guys. But what modular congruency says is that, let's say that, okay, let's just first write about what is multiplicative modulo inverse. From this, we will be able to find the congruency, right? Okay. So what is this multiplicative modular inverse? First, let's see what is multiplicative inverse. So if at any point of time you write a into b, which becomes equals to 1, right? So can I say that b is the multiplicative inverse of a? This everyone knows, I guess. Multiplicative inverse, basic multiplicative inverse. Okay, now what is multiplicative modular inverse? If you have something like a into b, if a into b is equal to 1, right, with congruency of mod m, then b is the multiplicative modular inverse. How many of you guys are able to understand this statement? And this is not equal to, this is congruency sign. So how many of you guys are able to understand this? So this states that a into b is going to be congruent to 1 with modulus m, right? So b is going to be the multiplicative modular inverse of a. How many of you guys are able to understand what I'm trying to say? So first, let's just see what is this congruency is, right? Let's just see what this congruency is. So this congruency is nothing. It says that if, let's say, x is congruent to y on mod z, it says, it is pronounced that x is congruent to y on mod z. This means that, yes, stranger, I'm explaining. This means that x minus y by z, right? X minus y by z has no remainder, right? It's completely divided. If it is completely divisible, then can I say that if you will do x mod z, it will be equal to the corresponding value y? Can I say something like this? Yes or no? Let's say 13 is congruent to, what should I write? 2 on mod 11. Why? Because 13 mod 11 gives you 2. And if I do 13 by 2 divided by 11, it will be what? Completely divided, no remainder. Does it make sense? So congruency means if x is congruent to y on mod z, it means that y is the remainder of x mod z and x minus y divided by z has no remainder. Does that make sense? Does that make sense, guys? Okay. Now we know that a into b equals to 1 gives you b as the multiplicative inverse. So what if you want something like a into b mod m to be equal to 1, right? For what value of b, a into b with mod of some value m gives you 1. This b is the becomes the multiplicative modular inverse. So let's say you have some values, right? Let's say a is equals to 5, and let's say m is equals to 5 also, right? So what will be the value of b? Or let's say, uh, I guess let's just change the values. Maybe we can take something like a is equals to 3 and m is equals to 5, right? What will be the value of b here? For what value of b, a into b mod m will be equal to 1? What, for what smallest integral value this holds true? Anyone? Shad, this is going to be true if m is prime always, isn't it? But currently, what will be the answer? Let's just say anything. Can I say b can be equal to 2? Because 3 into 2 mod 5 is equals to 1. Simple enough. So what I have written, if you have a into b mod m equals to 1, so b is the multiplicative modulo inverse, right? Okay. Now can I say that just this statement that I have written and this statement, that is a into b is congruent to 1 on mod m. Do you think both of these holds true, like both of these are equal? Quickly just drop a yes or no in the chat. Everyone, how many of you guys think this is like correct? Okay. Now, what's the question is, given the value of a and m, find b. Given the value of a and m, find b. Anyone? This is the question. That you are given this a, you are given this m, and you know this will hold true for any b because b is going to be the multiplicative modulo inverse. Find b. How you can do that for any value of a and m? Anyone with any approaches? Guys, this is clear to everyone. This congruency is clear to everyone, because if this congruency is not clear, nothing will be on the right track for you guys. You won't be able to understand a lot of things. Is this congruency part clear to everyone? Guys, say yes or no if this congruency part is clear to everyone. Cool. Okay. Now, anyone? What will be the value? Cool, Bharat. Okay, so Bharat Singla is here. Bharat Singla is here. If I'm not wrong, uh, so all those guys who don't know about Bharat, he's, if I'm not wrong, if you are the same Bharat who I have taught, so he was my student like last year or last to last year. He's like in ninth standard, and he's like currently uh, uploading a lot of editorials of the CodeChef long challenges. So you can definitely check them out, right? And see if like you are able to understand those problems. He like adding the solutions for harder problems like segment trees as well, and he's just in ninth standard, so quite a prodigy. So although Bharat has written the right answer, but what about rest of the people? What about rest of the people? Any thoughts how you can solve this? I've like written few things previously. Just keep everything in your mind and then give me some possible answers. Okay. Guys, shall we start or you need more time to think? Quickly just drop a yes or no, everyone. And guys, make sure that you keep dropping messages in the chat so that I'm able to understand what's going on your side. Are you able to understand few things or not? Right? Because this is like you are able to see me or like you're able to see what I'm telling, but I'm not able to directly interact with you, right? So the only way we have is your texts. So the more you will write, the better I'll be able to understand. And we have a TA with us as well. So like consume the resources as much as possible, right? Okay, so Piyush says 30 seconds. Okay. गाइस अभी तक जितना भी कुछ पढ़ा है वट एवर आई हैव टॉट टिल नाउ लाइक शुरू से अभी एक बार ये देख लेते हैं हम लोगों ने क्या क्या डिस्कस करा है 20 पेज भर दिए हैं हम लोगों ने आई डोंट नो हाउ बट ठीक है हम लोगों ने मॉड्यूलर अरिथमेटिक पहले तो थोड़े मॉड्यूलर अरिथमेटिक से स्टार्ट किया ठीक है क्यों जरूरत थी क्या जरूरत थी उसके कुछ रूल्स वगैरह देखे कहाँ पे रूल्स चेंज हो जाएंगे तीनों रूल्स देखे देखा कि डिवीजन में सीधा अप्लाई नहीं हो पाएगा राइट उसके बाद मॉड्यूलर एक्सपोनेंशिएशन के ऊपर ध्यान दिया उसका आइट्रेटिव और रिकर्सिव सॉल्यूशन उसका रेकरेंस वगैरह लिखी आइट्रेटिव सॉल्यूशन को ड्राई रन करके कोड करा देन वी स्टार्टेड विद एक्सटेंडेड यूक्लिड एल्गोरिथम एक्सटेंडेड यूक्लिड एल्गोरिथम में हमने देखा कि एक्स प्लस बी वाई इक्वल्स टू जीसीडी ऑफ ए कॉमा बी है तो ए और बी तो हमें पता है एक्स और वाई निकालना है तो उसके लिए हम लोगों ने कुछ कुछ डेरिवेशन करी क्या डेरिवेशन करी कि रिकर्सिव रिलेशन से उसको मैप कर दिया और बी और ए के कोफिशिएंट्स को मैच करके एक्स और वाई की वैल्यू निकाल ली ठीक है कोड कर लिया है हम लोगों ने इसको और इसके बाद अब हम लोग देख रहे हैं मल्टीप्लिकेटिव मॉड्यूलो इनवर्स मल्टीप्लिकेटिव मॉड्यूलो इनवर्स क्या कहता है कि इफ a into b is congruent to 1 on mod m then b is the multiplicative modular inverse of a right and when I say x is congruent to y on mod z it means that x mod z is y and x minus y by z is going to give you no remainder. So now you have this value a into b is congruent to 1 on mod m. You have the value of a and m. You have to find b. Anything? Okay, Oscar. I'll ask them to like open them up. So there is a feedback that the Kunal that the feedback form is blocked by the owner. So maybe can you ping someone who can like unblock the feedback form in the description? Guys, shall we start? Shall we start the discussion? Or you guys want some more time to think? Shall we start? Okay. Only Piyush is replying in the chat. What about rest of the people at an academy? Okay, so yeah. So Bharat is here. Bharat OP हो जाए यार एक बारी chat में. मतलब he is like one of the finest students I have taught till now, and is like breaking all the records in just ninth standard. So like I'm really happy to be uh, uh, one of his mentors because I'm sure a lot of teachers are teaching him in this age. So he's like doing really great. You can definitely watch out the lectures of Bharat on Learn Competitive Programming with CodeChef. He adds the editorials with a lot of more people. So do check that out. Okay, cool. So now we want to calculate this value. Now, can I say that a into b minus 1 is going to be mul uh, is going to be the multiple of m? Can I say? Guys, can I write this? A into b minus 1 is going to be multiple of m because a into b mod m is going to be giving you 1, then ab minus 1 is going to give you multiple of m. Does that make sense? Okay. Now, if ab minus 1 is multiple of m, can I write it as mq? For some value of q, mq is going to be a multiple of m. This is what? Multiple of m. So what I'm trying to say is ab minus 1 is equals to mq. And I can say ab minus mq is equals to 1. And ab plus m into minus q is equals to 1. And ab plus m into capital Q is equals to 1. Does that make sense? Now you have the value of this a, you have the value of this m. What you want to calculate? You want to calculate this b. So don't you think you can just directly solve it using extended Euclid algo? Can we say that? And this is going to happen only when GCD of a comma m is equals to 1. If this is the case, then only you will be able to calculate the multiplicative modulo inverse, because here you can see in the RHS you have what? GCD of a comma m. Can I say that? So if a mod m, sorry, GCD of a and m is going to be equal to 1, then I say AB, for AB congruent to 1 on mod m, this B is the multiplicative mod inverse. Can I say that? Guys, can you calculate this value B and this value Q? At last, we don't need Q, we just need this B. Does that make sense? Guys, everyone just drop a yes or no in the chat. Let me know if you are able to understand these things, whatever I'm trying to tell you guys on multiplicative modulo inverse. Yes, Piyush, like this is the same equation, no? This is the same equation that we have just saw, that ax plus by is equals to GCD of a comma b, and RHS is what? 1. Then GCD of a comma m should be equal to 1, and this a is already given. You have to calculate this x and this y, right? B is also given in form of m. You have to calculate x and y, and whatever the coefficient of a is going to be what? Your mod inverse. Can I say that? Everyone just drop a yes or no in the chat. Yes, so Shad is saying yes, very logical use of extended Euclid, but it's a little hard to think for the first timer. Yes, that's why like you are here, right? Don't expect that whatever you have learned till now is going to be everything that you need for competitive. There will be new topics obviously every time coming day by day in day out, so you need to be learning a lot of things. Although to learn those things you can use some intuitive learning on whatever you have learned till now, and use those intuitive learning directly and implement a lot of things, right? So try to map the things that you have already learned with. If any new concept comes, like let's say, let's just take an example. So there is an algorithm called as Z algo, and there's an algorithm called as KMP. These are pattern matching algorithms, right? For sure, like in your elementary class, in schools at least, no one teaches you this, how a Z transformation functions or LCP array or things like that works. But if you will learn these algos, you will see that okay, these are intuitive enough. These are like logical. If things are going to work in this way, then this will definitely happen, so on and so forth. Few things are there you that you already know, but don't expect that you will be having the knowledge of everything. You just need to like map it here, right? Like segment trees, things like segment trees are intuitive to think, but for the first time you need to learn it from somewhere. It won't like generally strike you that there should be something like a segment tree, right? Does that make sense, guys? Till now, is everything clear to everyone? Yashveer, you have written a wrong equation, don't you think? It is not equal to. As I said, this is congruency. Congruency is a different thing than equals, right? Yes, so Piyush is saying that sometimes it happens that you need to rewatch the video once and again. It makes sense because watching it once, what happens is whatever I've taught in 2 hours, the things that I taught you guys in the first 30 minutes, sometimes like doesn't retains a lot of time. So you need to rewatch it again and again so that the retention power is increased. You are able to revise everything, and you are able to see those things that you might have missed in the live lecture. So the main agenda of live lecture is you can interact with the instructor, right? I can record this video and just provide it to you, no issues on that part. It will be like really very easy for me. A 20-minute video will suffice the whole extended Euclid algorithm. But the thing is that in a live lecture you can ask at least some live doubts, right? That you won't be able to ask in the recorded video. And whenever you will be watching this recorded session, then a lot of things will get revised. if you missed anything, then you will be able to catch it up, so on and so forth, right? Does that make sense? Ananjay, I guess this is your first message on YouTube. I'm not sure if some of the messages nowadays are not coming on YouTube. Uh, Anjanay, sorry. Kunal, are you able to see any message from Anjanay? Did we miss any message from Anjanay? Can you check on YouTube? Guys, till then, everyone say yes or no if this point is clear to everyone. Just drop a quick yes or no in the chat. Anjanay, I'm not really, I'm sorry if I missed any of your message, but I'm not able to see your messages. Like I just replied to Yashvir. That was a message on YouTube only on the comment. I was really not able to see your message. I'm really sorry for that. Sometimes it might happen on YouTube. I'm not sure. Cool. Guys, shall we resume? Shall we resume? Okay, so I guess starting with linear Diophantine equation won't be completed. So there was a question in the last lecture that was ADA GCD. ADA GCD that was from Spodge, right? Few people were requesting for the code of that problem. So let me bring that problem to you guys. First, this is ADA GCD. Okay, so this is a very simple problem. Yeah, Sheikh, I will share the notes. Don't worry. Just give me 10 more minutes. I'll share you the notes. So the problem was very simple. You have to calculate GCD of n numbers, but the numbers were not directly given to you. The numbers were given in the form of multiplication of multiple numbers. So what was the approach that we decided? We decided that we will go with the elementary maths approach of calculating the GCD, that is to calculate all the factors of the number and taking out the common factors. Does that make sense? This was the approach that we discussed yesterday. If anyone has missed that part, you guys can definitely check out the lecture that I conducted yesterday on Introduction to Number Theory 1. Guys, is this point clear? What was the approach that we decided for? Yes or no? Okay, so let's just try to code it. Let's just try to code it. So problem is ADA GCD, I guess. ADA GCD dot CPP. Okay, let's just bring our basic template. Cool. Okay, right. So first of all, let's just try to make a sieve. Why to make a sieve? Because instead of calculating the factors in root n time, we can calculate them in log n time. So we can just make a sieve out of it. Does that make sense? Guys, say yes or no in the chat. We can just make a sieve or prime sieve. I guess everyone know about prime sieve. If not, then I've also taken one free lecture on that part. You guys can definitely check that out. So I'm skipping the part for creating a sieve. I'm just skipping the part for creating a sieve, right? You guys can definitely create a sieve on your own. If required, I will code it. Don't worry. Make a sieve, right? Okay. Now let's say you have a sieve already calculated, right? Let's say you have a sieve already calculated. Then how you can like solve the problem? So you will be getting n numbers. So int n, c in n, right? So loop from I 0 to n minus 1, right? Every time you will be getting what? A new number mi, c in mi, or let's just write it as ai, right? Ai represent what's the number of uh, the count of numbers that are going to represent the original number that should be here. So multiplication of these numbers are going to represent that number. Does that make sense? So we have also taken the input for that. So again, we are going to loop from j equals to 0 to ai minus 1, right? We will take input of ai numbers. Does that make sense? It's just to take input from this input.txt file if we are in a normal environment, if you are not in an online judge environment, right? You can ignore that part. It's like, guys, you can ignore all this part. This is just a basic template. Avoid this. Focus on the logic only, right? Focus on the logic only. Okay, so every time you will be getting a number, let's say D. Let's say you will just do C in D. Now what you need to calculate? You need to calculate all the factors of D. So what I'll do, I'll make a map int comma int MP, right? And inside this map, I'm going to store my factors. So while D is greater than 1, what I'm going to do, I'll do MP of, now inside my sieve, I can store what? All the prime factors, right? So I'll make a sieve in a way, I'll make a sieve in a way that at the ith index of the sieve for a composite number, I have the biggest prime factor stored, right? Can I make a sieve in this manner, guys? Can I make a sieve in this manner? Okay, let's just make it. Let's just not try to avoid it. Let's just try to make one sieve. Like, does that work? Will that work for you guys? Let's just make one sieve. So let's just make thing like ll sieve, or we can make it int only. Int sieve, and let's just make it of 10 raised to the power 7 plus 1 size. Right, we'll make a sieve, and initially what we are going to do, we are going to loop over this whole thing. That is, we are going to loop from, let's just define it as, let's just define one macro here, hash define uh, max L as 1 E7 plus 1, right? So this is maximum limit. I'll make a sieve till max limit, and starting from 0 to max limit minus 1, I'm going to iterate. Does that make sense? And what I'm going to do, I'll just do sieve at I equal to I. Initially, I can just initialize my sieve like this, say a yes or no, guys, by default values. Now I will do that filtration algorithm, right? How that filtration algorithm will work? We can start from for LL I equal to 2, right? I less than max L, I plus plus, right? We are going to go for every number. And if sieve at I equals to I, right? This will mean what? We are at a prime number. For a prime number, we will store at ith index, we will store the value I only. Now what you can do, for int j is equals to, we'll start from 2 into I. We'll go for j less than max L and j plus plus. Yeah, j plus equal to I we can do. What we are going to do, we do sieve at I equal to I. If you will create a sieve in this way, can I say that for any composite number I, it will be storing you the biggest factor? This is j. For any composite number j, it will be storing the biggest factor, because let's say you are at 6. So 2 will first cancel out 6. So sieve at 6 will be equal to 2. Then when you will come with 3, then sieve at 6 will store 3 here. Does that make sense? So you can modify your sieve code anyhow that you want, right? It's just on you. So now if you have the sieve calculated, can I say map at sieve at, what's the current value? D. We will store it with one iteration, and in the next iteration we'll do D divide equal to sieve at D. Does that make sense? Will this code will help us to give all the factors and store it inside the map MP? Everyone, say yes or no in the chat. Guys, drop a yes or no if this map will be storing all the factors of the number D. And similarly, multiple D's will come, so it will eventually store all the factors of number AI. It will store all the factors of this number AI, because AI represented as multiplication of multiple D's. So factors of D's are eventually the factors of AI. So we can get that. Does that make sense? Guys, say yes or no if this point makes sense. Okay. Now, what we discussed, as soon as you have the factors of this value and this value, you will eliminate out what? Non-common factors, you will remove them. Say yes or no. Can you guys remove them? So what we can do is we can keep one more like array. Let's say let's just keep one more array. We can keep it like int uh, elimination array, right? And this will be also of limit max cell. And let's just initialize elimination at I equals to let's say max cell only, right? We'll initialize it with maximum value. Now we are going to do that elimination algorithm. So whatever your common factors are, we will just store them, right? So let's say you have 2 raised to the power here. Let's say in 36, what is the power of 2 in the factors of 36? What is the power of 2 in the factor of 36? 2. What's the power of 2 in the factors of these numbers? 2 raised to the power 3. What's the minimum value? 2. So the common will be coming as 2. Only 2 raised to the power 2 will be coming as common. Say yes or no. So what I can do is for auto it is equals to mp dot begin. I will move to all the numbers. It not equal to mp dot end it plus plus. Right. I will go to all the factors that I've stored in mp. Right. I'll go to all the factors. Now what we can do? We can check that what's the value stored in the elimination array. Elimination of star it dot ff. Ff is what? First, because I've already defined a macro for it, right? itfff. So we are going to store minimum of whatever we have at elimination of ff, comma star it dot second or ss. So first time it will be storing infinity. So all the factors 2 raised to the power 2 comma infinity, sorry, 2 raised to the power 4 comma infinity, minimum value is 4, so you will store 4. 3 raised to the power 1 comma infinity, minimum value is 1, you will store 1. So after one iteration, this elimination array will be having all the powers of factors of the first number. Then in the second iteration, minimum array will be containing all the common factors from first two. Then after third iteration, it will be containing all the common factors from first three, so on and so forth. Can you guys see that? We can just keep a minimum like this. Say yes or no. Guys, say yes or no in the chat. Now at the very last, you will be having all the factors in this elimination array. Can I say that? You'll be having all the factors after all the iteration. You just need to calculate the GCD. Right, and the GCD will be what? The product of all the numbers and their powers. So let's say at last we got 2 raised to the power 2 into 3 raised to the power 2. So the answer will be 2 into 2 into 3 into 3. So can you guys do that part on your own? After this elimination part, can you guys do that part on your own? Or do you want me to do that one as well? I can do that, no issues. But do you guys want me to do that? Guys, you have got all the common factors that you used to do in your elementary mathematics. You've got all the common factors in this elimination array. What you can do, you can just iterate over this elimination array and get all the values. Can you guys do that? Right. So let's just keep this part as your on you. Like it's just now to calculate the GCD. Try it after this code template. Try it. Otherwise, maybe I can share you the solution. Also, if you guys want the notes for today's class, let me share you the notes as well. Just a second. So today we learned extended Euclid, right? Cool. So guys, just give me 1 minute. Let me share you the notes. Just 1 minute. Guys, till then, everyone, let me know if you are able to understand the logic that I have written. If you guys are able to understand the logic that I have written, just spam a yes or no in the chat. I'm sharing you guys the notes. आनंद says yes. Elimination का एक बार और समझा दो. बिल्कुल शायद एक बार ही और समझा देते हैं. Just give me 1 minute. Extended Euclid. Cool. तो एलिमिनेशन का मैं क्या कह रहा था? देखो, इनिशियली एलिमिनेशन एरे में मैंने इन्फिनिटी भर रखा है, 10⁻7+1 भर रखा है. स्ट्रेंजर कोड शेफ या कोड फोर्सेस पे तुम फिल्टर करके निकाल सकते हो ना किसी भी टॉपिक पे. यू कैन प्रेफर दैट, राइट? ठीक है. फर्स्ट आइट्रेशन के बाद किसी भी, अब मैप में मैंने क्या स्टोर करा है? मैप में मैंने स्टोर करा है कि अच्छा मान लो 2 एक प्राइम फैक्टर था जो डिवाइड करता था एआई को, तो 2 की कितनी पावर डिवाइड करती है? तो लेट्स से 2⁻³ डिवाइड करता है. अच्छा, तो मैं क्या करूंगा? मैं कहूंगा कि अच्छा एलिमिनेशन एट 2 पे अभी क्या पड़ा है? एलिमिनेशन एट 2 पे अभी पड़ा है इन्फिनिटी, और मुझे अभी 2 के कितने फैक्टर मिले हैं? 3. तो दोनों में से छोटा क्या है? 3 है. तो मैंने कहा, क्या कहा? अब मैं एलिमिनेशन एट 2 पे 3 स्टोर कर दिया, क्योंकि 2⁻³ इज अ फैक्टर ऑफ एआई. डज दैट मेक सेंस? तो पहली आइट्रेशन में ऐसे एआई के पहले नंबर के सारे फैक्टर आ जाएंगे. अब अगली आइट्रेशन में एलिमिनेशन में सारे इंडेक्सेस पे तो इन्फिनिटी नहीं पड़ा होगा, कुछ कुछ इंडेक्सेस पे तो असली पावर पड़ी होगी. तो जब सेकंड नंबर आया, तो मान लो सेकंड नंबर की 2 की पावर आई 1, तो अब मुझे कॉमन निकालना है. तो 2⁻4 में से और 2⁻1 में से कॉमन क्या आएगा? 2⁻1 कॉमन आएगा. तो मैं चेक करूंगा, अच्छा एलिमिनेशन एट 2 पे अभी क्या पड़ा है? एलिमिनेशन एट 2 पे अभी पड़ा है 4, और मेरी पावर कितनी आ रही है? 1. दोनों का मिनिमम 1. तो मैं स्टोर कर दूंगा 2 पे 1, क्योंकि यही कॉमन आया. डज दैट मेक सेंस? Cool. So I've also uploaded the notes. So let me share you guys the link. Extended Euclid. Copy. I'm sharing the link in the Unacademy as well as YouTube chat. Kunal, can you like also ping it in YouTube? Sometimes my chat doesn't go on YouTube. I'm spanning it multiple times. Can you also like send it on YouTube? I've pinned on the Unacademy platform. Cool. Okay, just give me 1 more minute. Okay. So guys, was today's lecture informative enough? From last 2 lectures, are you guys feeling that you are getting a hold of number theory, how things work with number theory, what kind of maths you can expect in number theory? Are you guys able to get a hang of it? Does that make sense? Guys, say yes or no in the chat. Are you guys able to understand how things work in number theory and what you can expect from number theory? Because in the next class, we are going to discuss some more concepts around number theory. We are going to solve some linear Diophantine equation and some cool more concepts. We are going to learn about number theory in the next class, some divisibility concepts, some more theorems we are going to learn. And that will be the last lecture of this micro course. Also, do let me know in the chat of YouTube what more micro courses you want, because I'll be coming with multiple micro courses every week that will be free. So what more micro courses you want, like introduction, that you want to get a head start on something, so I can like have a 3 lecture micro course on that part. So do let me know in the YouTube chat whatever your suggestions are, and also drop your comment that do you guys like the lecture, was this informative enough? And one humble request from my side to everyone, actually two humble requests. Don't spam the YouTube chat and be interactive in the YouTube chat. Does that make sense? थैंक्स शाद. मैथ ओपी हो जाए यार एक बारी चैट में, अगर सबको लगा कि मैथ इंटेंसिव लेक्चर था एंड यू गाइस वर एबल टू गेट अ हैंग ऑफ द थिंग्स. ठीक है सौम्यदीप, वैसे मैं सोच भी रहा था कि कुछ बाइनरी सर्च ट्री पे कर लूं, क्योंकि बीटी बीएसटी को मैं 3 लेक्चर में कवर भी कर सकता हूँ, एंड काफी इंटरव्यू लेवल प्रॉब्लम्स हम लोग काफी डील कर सकते हैं, कुछ कॉम्पिटेटिव लेवल प्रॉब्लम भी डिस्कस कर पाएंगे. तो एटलीस्ट बाइनरी ट्री पे 3 लेक्चर तो करे जा सकते हैं. बीएसटी पे मैं उसको इंक्लूड कर पाऊंगा तो बीएसटी के थोड़ा इनजस्टिस रहेगा, क्योंकि बीएसटी को 1 लेक्चर दूंगा या 2 लेक्चर दूंगा तो बाइनरी ट्री के लिए इनजस्टिस रहेगा. लेट्स कीप इट लाइक बाइनरी ट्री. लेट्स इट ओपन एंडेड बाइनरी ट्री. We are going to start where we can like from very scratch code the binary tree, get some hang of the interview level problems, and get some hang of the competitive level problems as well. Will that work fine in the next micro course? Although the last class of this micro course is on Thursday, do attend that one as well. That is also going to have a lot of great mathematics content in that. Guys, will binary tree as a micro course work for you? Let me know in the chat of YouTube. Will that work for you guys? Right? Okay, okay, cool. So guys, let's just wrap up today's lecture. It was like a really, really awesome experience to have a discussion with you guys on modular arithmetic, extended Euclid algorithm, and modulo inverse and problems around that. Right. So Shad, for persistent segmentary and DSU, you can definitely join the camp. Right. So I guess DSU is not conducted in the camp. DSU I'll do. I'll do DSU. Micro course on DSU planned, and binary tree planned. Works? Does that works? DSU को बिल्कुल ही फोड़ देंगे. DSU बिल्कुल ही फोड़ देंगे. DSU काफी सही है. ठीक है. User, I can take that. Like I love open source things. I'm a former G Soccer for Harvard University. I'm not sure if we can take an open source lecture, but I will definitely take up your request, and I will be really, really happy to take a lecture on GitHub. Shaik, generally I try to think in the terms like whatever I have learned till now, if I can map my already learned theory with the current problem, or any patterns that I can observe, or any straightforward algorithm that I can observe. If these three things doesn't work, nothing works for me at least. I then try to watch like what kind of things can be applied, or maybe read 2 3 lines of editorial, or before that read the tags, what topic this problem is from, and then make a brute force of the concepts of the topic, so on and so forth. This is my strategy to go for, and this strategy works really great for me in concepts like DP and maths. Does that make sense? Uh, Piyush, again, I love system design as well, but I'm not sure on competitive platform I can like do that or not. I need to take some, I would say, uh, approvals, but let's see. Right, let's see. Cool. Till for now, let's just wrap up, and I hope that you guys liked the lecture. If you guys like the lecture, then do drop your comments, whatever your doubts you are having, whatever suggestions you are having for me. I know there is always a scope of improvement for everyone. So there should be some scope of improvement for me, for my teaching style. Whatever you feel, do drop your comments, and I'll be really happy to take up that. And it was really, really awesome to teach you guys the concepts of this modular arithmetic and Euclid's algorithm. And we'll meet in the next video. So till then, take care, guys. Bye bye. Stay healthy. Good night, and keep coding. शायद 2 दिन में शायद लाइव हो जाएगा. 2 दिन में लाइव हो जाएगा, तो मैं पूरा स्केड्यूल मिल जाएगा उसका. मेक सेंस. चलो. गुड नाइट गाइस, टेक केयर, बाय बाय. गुड नाइट. थैंक्स, थैंक्स स्ट्रेंजर. गुड नाइट, गुड नाइट, गुड नाइट एवरीवन.